Hi everyone, welcome back. And today we'll be solving one of the most popular questions on LeetCode, that is two sum. Now this is a very easy question and we'll be looking at two possible approaches to this question using visuals as we always do. So first things first, let's understand what the question statement says. So we are given an array of integers nums and we are given an integer target and we need to return the indices of the two numbers such that they add up to the target. So for example, this is the array given nums is 2, 7, 11, 15. We need to find two elements that add up to the target that is 9 and we need to return the indices of those two elements. And if there are no indices, then we can return -1. Okay, so the question says we have exactly one solution, so we don't need to return -1. Alright, so this is the two sum algorithm visualization. So for example, you know, what we have to do is that for example, this is given array and target sum is 9, the solution would be 0 and 1 because 2 plus 7 equals to 9. So we can input any array that we want. For example, let's add more numbers. Let's add 7. No, 7 is already there. Let's add a 9 and let's add 14. Okay, 13. Let's add 13. And let's first check the brute force approach solution. So in brute force approach, we'll check every pair of element that can exist in the array. So the first step is we take element 2 and freeze it. And then we traverse through the array, selecting every single number and checking if the addition of those two numbers give us the target. So let's say 2 and 7. 2 and 7 leads to target 9. Okay, so solution found. We don't need to do any other step. Let's change the target to, let's say, 22. Let's change the target to 22. Then what we'll do, we'll traverse through the array. So we take 2 and we get back to 11. It sums out to be 13. The target is 22. Next step. 17. Target is 22. Next step. Sum comes to be 11. Target 22. Next step. 15. 22. Next step. And we'll go through all of those traversing and we get to 22. So 7 and 15 give us 22 and their indices are 1 and 3. So we just return 1 and 3 as an array. This is the brute force solution. Now let's check the hash table solution as well. So what we'll do in hash table solution is we'll check, we'll freeze one single number and then check if the next number, if this number gives us the target value. So this is a single element, right? And we need pair. So we assign the key as 2 and we increase the value of the key to 0. So 0 is the index of element 2 and element is the key of the hash table. Let's go to the next step. 7. Now add to hash table 7 at index 1. So 7 is the key and value is the index of the element 7, that is 1. Now we check hash table complement 11 for index 2 and we do the same. Now we check complement 7 for index 3. So basically 15, we have a target 22. So 22 negative 15 is 7. So we need an element 7. We need to find element 7 in the hash map, right? And we found element 7 on the hash map. So now this button will not work next step because we don't need to go next step as we have already, inputted element 7 in the hash map already, remember? So it will just check if element 7 is there or not. And since element 7 is there, it gives the solution found and it returns us indices 1 and 3. Now let's code both these solutions together. So for the brute force solution is easy. We just take the size of the array and we apply two for loops. from I equal to 0 to n and j equal to I, and we check if nums of I plus nums of j is equal to target. If it is true, then we just return the indices, that is, we return I comma j, right? And if and since we have to return a vector, and since there is always an answer, we just return an empty vector. Hope this works. Okay, why does this not work? Nums of i's. Okay, we need to do I plus 1. Yep, let's submit it. Okay, so it works. Now let's check what the hash map solution was. We do similar thing. We take the size of the num vector, then we make a hash map or an unordered map of int and int. Let's call it m. Now we apply a for loop, int I equal to 0, I less than n, I plus plus, and we initialize a variable. Let's call it what do we call it? Complement. Let's call it complement, which will be target minus nums of I, and we'll check if this complement exists in the hash map or not. So m dot find, so find if complement exists in the hash map or not. If it does not, equal to m dot end, then you just return those indices which are I and map of complement. Because remember, the value of this key holds the indices. And now, if if the complement does not exist in the hash map, you just add it. You just add it. So m of complement, m of nums of I is equals to I, and we just return. What do we have to return? We have to return a vector. Let's return an empty vector. Let's submit it. See if this works. Yep, it does. And this is a way better solution. This is a way better solution. And I'll tell you why. Look at this graph. Let me zoom out a little bit. So, the key takeaways are brute force is simple but inefficient for large inputs. The time complexity of the brute force solution was O n square, big O of n square. So if n is sufficiently large, brute force become inefficient for large inputs. But hash table approach offers a significant speed improvement because hash table has a time complexity of big O of n. So if even if n goes sufficiently large, it will not be a problem. This is a this is a trade-off between time and space complexity basically. So this was the solution, guys, to do some problem. I hope it would help. And if it helped, consider subscribing to the channel. Thank you.